Now let's see this question. Like actually this question is looks very simple, but in future once we apply the same things, okay, people frankly will be confused. Okay, now anyway, see this question. The two electrical subnetworks N1 and N2 are connected through three resistors as shown in figure. The voltages across 5 ohms resistor and 1 ohm resistor are given to be 5 ohms resistor is 10 volt, already they have given, and 5 volts here across 1 ohm resistor respectively, then voltage across 15 ohm resistor. Okay, problem here is they did not give the what they say polarities of the voltage. Okay, so see here, for example 10 volts 5 ohms, in the sense current entering in this direction is 10 by 5 is going to be 2 amperes. Okay, because plus terminal. Okay, so my current should enter into the plus terminal because it's a passive element. Now 5 volts 1 ohm, so this is going to be 5 amperes. So from here to here 7 amperes is entering from N1 to N2. Now N1 is one subnetwork, sorry, N2 is one subnetwork, N1 is one subnetwork. So 2 amperes plus 5 amperes, 7 amperes has to enter here. That's obvious. Okay, because written part should be there for the current. So the moment 7 amperes enter here, plus minus voltage is going to be 7 into 15. Okay, 7 into 15 is going to be 105 volts. But the problem here is, like, the moment they have given 15 ohms here, they asked the voltage only, but they did not give the polarities, because if they have given polarities like this, it will become plus 105 volts. If they would have given polarities like this, it would be minus 105 volts. So both the options should be right. Plus 105 and minus 105, both the options would be right. Okay, now let us see one more question. This question. Okay, so basically let us solve this question. The figure in the figure, the value of resistance R is, okay, the value of resistance R is. Basically means without actually they have given good information, because it's old gate question. Normally, like in gate, they will not allow you to take means 2-3 what do you say equations and solve. Maximum 2 equations they may give. Okay, but preferably it will not go beyond 2 equations. But anyway, let us try to solve as it is, without focusing on much on 10 and 5 amperes. Okay, so for example, how many nodes are there here? 1, 2, 3, 4. 4 nodes are there. Out of 4 nodes, because we have to compare between nodal analysis and mesh analysis. Okay, so shortcut I will tell you at the end. 1, 2, 3, 4. 4 nodes are there. 1 reference node, 3 nodal equations, and this particular source is connected with respect to reference. Means a direct relation. This voltage source is connected with respect to reference. So directly this voltage is going to be 40 volts. Directly this voltage is going to be 100 volts. So 2 gone. So only one equation we are supposed to write here. Okay, just let us write the equation. For example, this is V. Okay, so if I write KCL here, V minus 100 by 14, current leaving in this direction, and current leaving in this direction is going to be plus V minus 40 divided by 1. Current leaving in this direction is going to be plus V by 2 equal to 0. So from this you are going to get value of V. Okay, so once you get value of V, directly you can calculate current flowing through this, and 10 minus this current will give you this current. How much is the voltage across resistance? For example, with respect to this is 100 volts, so this is 100 volts. With respect to this is 40 volts, so this is 40 volts. So how much will be the voltage across resistance? 100 minus 40 is going to be 60 volts. So voltage already we know that is 60 volts. Okay, now current we can calculate once you calculate V. Okay, so that is a normal standard procedure. But if you closely observe the network, they are not asking you to solve this complete equation and all. Okay, so focus here. See here, they did not give 100 volt and 40 volt, but rather they have given 10 amperes and 5 amperes also. So means current here is 10 amperes, current here is 5 amperes. Now if I try to apply KCL here, that is the shortcut. Okay, so 10 amperes should go from here, and 5 amperes is going from here. So from this node leaving currents are 15 amperes, so entering current should be 15 amperes. If it is 15 amperes, voltage across this will be 15 into 2 is going to be 30 volts. So with respect to this as a reference, this is 30 volts. So you need not write equation at all. Okay, now once this is 30 volt and this is 100 volt, 100 volt, how much current will go through this? 100 minus 30, 70 by 14. So 70 by 14 is going to be, I think, 5, right? 5 times 5 to, yes, 5 amperes. Okay, now if you observe, 10 amperes is entering, 5 amperes is leaving, so remaining 5 amperes should leave from here. Already voltage across this, we know what is that. 100 minus 40 is going to be 100 minus 40, 60 volts. Now voltage, you know, current, you know, 60 by 5 is going to be, resistance is going to be 12 ohm. 12 ohm. Okay, so directly, basically in the gate exam, we have to focus. Most preferably, they will not allow you, or they will not ask you to write 2 equations or more than 2 equations. Preferably 2 equations, okay, we can solve. Okay, so the moment they have given this, if you try to apply KCL here, means problem is becoming simple. Of course, you can calculate this V of 30 volts by using equation whatever we have written previously also.